Good morning, everyone. It's a real honor for me to be able to introduce our headline speaker, Dr. Dwayne Beck. Robin and I had a chance to go up to his research farm, Dakota Lakes Research Farm, in August of 3 years ago. In fact, it was for her birthday. I told her I was taking her to South Dakota, and she thought she was all excited. We're going to the Black Hills, things like that. She just didn't know we got to go to somewhere better, right? A research farm. So anyway, really excited that Dwayne can be here. One of the things that really lacks in agriculture research is long-term system-based research. Because when you're looking at systems, how many jugs of stuff does that sell? Not much, does it? And unfortunately, our research at universities has gone from real discovery research to proving products right on short-term research. So Dwayne is part of a research farm that is owned by farmers, doing research for farmers in cooperation with South Dakota State University. So it's a really neat public partner research farm that has developed very good long-term information that we can all glean great things from. Plus, Dwayne will certainly challenge your thinking. I think if we all open our minds, okay, and do some new thunking, if we really look at what's going on in ag today, the definition of sustainable is we can keep doing the same thing over and over and over again in infinity, okay? And I think we've really hijacked that word. Sustainable, we say it makes us feel good, but really, can we do what we're doing today for 1,000 years? Okay? So Dwayne's going to challenge our thinking a little bit in those regards and help us, encourage us to do things and look at things in a different way. So without further ado, I'd sure like to welcome Dr. Dwayne Beck to the stage to challenge our thinking. Dwayne?
Well, good morning. After the speaker last night, I'm not sure that I can keep up to that, but we'll see. I have no brains to give out, so I got to keep all the ones I have. I guess I'll just get starting with Monty asked me to look forward in agriculture, and I'm not sure I'm qualified to do that. A lot of you might be better at that than we are. I think what we do at Dakota Lakes is very unique, and I think it should be a model for the future. But we're going to address this today. Where are we going? Well, that's really the wrong question. The right question is, where are we? I mean, you can't figure out where you're going to go unless you take a look at where we're really at today. And I think a lot of us are just kind of doing things and trying to keep up with the changes and keep up with what's going on, but we don't really know where we're at. So let's take a look around. We have fires in California, we have fires in Brazil, we have fires in Australia, we have floods in California, we have floods in the Corn Belt, we have floods in Australia. We have an ecosystem actually that's just really not functioning well. And we've gone through this before, right? Our aquifers are over appropriated, the lakes and rivers and oceans are degraded. I mean, in California, the whole water situation is an issue. And how are you going to address that long term? Start looking long term things. And we kind of went through a lot of this in the South Dakota as well and had to kind of come up with some answers. So our answers aren't your answers, but that's where we're at. Total subsidy for crop insurance in 2013 was $14 billion just to subsidize crop insurance. And this is at the time when they were talking about subsidizing health insurance, right? Obamacare. Well, if subsidizing crop insurance is a good idea, then subsidizing health insurance should be a good idea too, right? You can't have it both ways. I don't care what your politics are, but you can't have it both ways. Either you are or aren't for this silliness. And that same year, all of federal government money for research was $2.6 billion. $14 billion in subsidy, $2.6 billion in all ag research. That's USDA ARS plus the money that they send to the state universities and land-grant universities. It used to be the money they sent to the land-grant universities was in a block grant that went to doing long-term research. Now it's all in short-term NIFA grants, which are wagging, tail wagging the dog stuff, okay? Direct subsidy for agriculture in 2019 was $22 billion in addition to the crop insurance. I think we got a problem. We're getting our money from the government. Now, in the talk I gave in Kansas in 2014, I put it on how much per person did SNAP get, the subsidy for the people with not very good means in terms of food stamps, and how much per person that we got as farmers. Who do you think got more? Yeah, farmers per person by about 100 times. Okay? So can we defend that? Because we're going to have to. Total energy used on Earth in 2012 is 560 exajoules. Okay? Joule is a Newton meter, in case you want to know. I used to teach chemistry and physics. So Monty said, is there anything special about you? And I said, well, I used to be a chemist. I got my undergraduate degree in chemistry. So you think about things different if you're a chemist because you can't do trial and error research with chemistry. You end up blowing up the lab too often. So better know what you're doing. That's 1.6 times 10 to the 13 kilowatt hours. That's somewhere around 2 billion kilowatts running at all times, 24 hours a day right now. Okay? That's not the problem. 86% of this non-food energy is fossil fuels. 86% of the energy we're using right now is fossil fuels. If we didn't have the fossil fuels, then what the hell are we going to do? Well, the total sunlight energy on the surface of the Earth is somewhere between 1,600 and 40,000 exajoules. 1,600 is twice as much as what we're using, so we'd have to capture all the sunlight energy, right? Couldn't have any left for plants, and we'd have to capture all the stuff falling on the oceans and whatever to get, then we'd have half of all the sunlight energy would give us what we need. I mean, it's just a silly number, okay? So we, all of humanity, not just farmers, have a problem. And then I put this in there, even a man would need to ask for directions if you were that goddamn lost, right? I mean, we're men, we don't like to ask for directions. Well, it's about time we start looking for directions. So we can't figure out where we are if we don't know where we've been. So I took this as a challenge to look back and review what we've been doing. Humans in their current form appeared approximately 200,000 years ago. And for most of that time, they were hunter-gatherers. And they didn't really start to domesticate plants and animals until 11,000 years ago. Now, they had a very small population. And that was kind of limited because there's just not enough food to build big populations, right? So 11,000 years ago, they started to domesticate plants and animals. A human can average about 1/20th of a horsepower. So think of the exajoules thing, the 2 billion horsepower. An oxen produces about a half a horsepower. Not as good as a horse, I guess. So energy was a limiting factor. And when I talk about Dakota Lakes Research Farm and our history, the forces that led to us being where we are probably started when people started to domesticate animals and plants and do farming, okay? Early farming systems were polycultures, especially in the Western Hemisphere. We had the three sisters in the U.S. The three sisters are corn, squash, and beans, right? And they were grown in a polyculture. And the Europeans showed up and said, geez, here, get the plow, you got to do this, and then don't plant all them damn plants together. And the Native Americans are going, well, God, you're stupid, but whatever. And there were large civilizations built. I mean, one of the neatest civilizations, if you can study what they did around Mexico City, was a tremendous farming system that they used there. But even there, their negative feedback loops occurred. And for a lot of our Native Americans, what they do is they would farm until it got degraded to a certain extent, and then they would move on. But they'd be in these villages for a period of years, and then they would move on. Some of the South American and Mesoamerican ones lasted longer. When civilization became less mobile, when they started building cities, that increased the demand on the land. Energy was a limiting factor because you only have animals and people. All energy was biological and came directly or indirectly from the sunlight. And so they couldn't get very far. The products produced by sunlight were fuel, feed, and food. And if you use too much of your energy for feed, for instance, for animal traction, then you reduce the amount of food or the amount of fuel. So it was always playing that game. And we have a lot of people say we're going to go to biofuels and whatever. Well, we're going to play that same game again. And again, if you harvested all the sunlight energy, you still don't have as much energy probably to use as what we're using right now. So that sounds good on the commercials, but progress was limited because there was not enough energy to both produce the food and transport it elsewhere for sale. Transportation was a huge problem. If you take a Central American or South American Native American and send him off with corn somewhere, he'd had no beasts of burden. So a man had to carry that. Well, he could only go so many kilometers before he'd used up as much energy as what he was carrying. You're really limited unless you have water or something like that to go on. There was not enough food and feed to build cities and fight wars, so empires like the Romans began to expand their territory and increase the food production. So they got more land and they got slaves because they needed that work power, right? That's one of the reasons for slavery, is that we did that in the United States, actually. That's why we had slaves. We needed the energy. We couldn't do that couldn't grow the cotton and feed the guys and feed that cotton into Europe, right? Unless we had slaves. We're doing the same thing now. We're doing the same thing now. Get big or get out. Our Secretary of Agriculture, right? Get big or get out. Well, you're just expanding your land base trying to get big, but are you doing it better? See, so especially in the central part of the United States, we got this kind of get big or get out thing, but you're just doing the same thing they used to do. Several centuries of empire building by Europeans and Asian countries, and even some in South America, between Roman times and Industrial Revolution. In all cases, again, they're just trying to get more food, fuel, and feed for progress. Several years ago, Ruth and I went to France. I did a series of meetings in France for Frederick Thomas, and we'd go city to city in a car that had an English-speaking GPS, which is, it didn't give us the swear words that people were saying when we went by, but did something wrong. But other than that, it was all right. And every city we went to, they would take us and say, well, you've got to see our castle. Every city has a castle, and they'd show you the castle, and, oh, this is great. And you see one castle, you've seen them all, but it's interesting to me to look at those, and I'd say, well, where'd they get the grain to put in the granaries? Well, they grew it around the castle. And I'd say, well, if you look at that ground, it's so degraded, nothing will grow there. And then it started to hit them. What had happened is they degraded all the land, and then the castle filled. It's like a lot of civilizations, right? So there's land in France. Oh, looks like California. In a few places, yeah. Okay, that's what it looks like, and they're plowing 2 feet deep or 3 feet deep, and in the bottoms of the valleys, they are so unproductive that they're now plowing on the sides of the valleys. And some of the valley walls are so steep they can't go sideways on them, and they can't pull up, so they drive up and plow down and drive up and plow down. So when it gets degraded like that, exploration, outmigration is a consequence of degradation. New land needed to be found and exploited. I told them in my talks that my ancestors left Europe because the land was so degraded they couldn't make a living anymore, and they went to the United States to find more land to degrade and had done a very good job of it. Okay? We've only been here 100 years or less. You know, and a lot of homesteading in the middle of the United States was done in the early 1900s, and at most the late 1800s. But the French sent out some explorers by the name of the La Vérendrye brothers. They left Winnipeg, Manitoba, went across the Continental Divide, which is about as tall as this podium, between the Red River Valley and the Missouri River Valley. There's just a little tiny rise that splits those two rivers, and that kind of defines the Canadian border. The U.S. is in the Missouri River Valley, and Canada is in the Saskatchewan River Valley. It goes into the Hudson Bay. But they crossed into the Missouri River Valley and claimed that area for France. And there was a lead plate buried above Fort Pierce, South Dakota. I'm from Pierre. Fort Pierce on the other side. In 1743, it was found in the 1930s, claiming this area for France. That's why we bought the Louisiana Purchase from France, because that was their claim to that central part of the United States. And then we came to the United States, and we have George Washington and Thomas Jefferson and Alexander Hamilton saying a few more years of increased sterility will drive the inhabitants of the Atlantic states westward, because we're degrading the soil in the eastern seaboard so bad that we need more land, or we got to do a better job here. Like, duh. So they said, well, we should do a better job, but shit, we'll just buy the Louisiana Purchase and move west. Right? So here we are. We got Lewis and Clark coming up, my buddies, Lewis and Clark, coming up the Missouri River. Dakota Lakes Research Farm's right here. If you read their books, there's the big meander. They talk about the big meander, and they come around what we call the pocket, and then we're right on the west side of the pocket, and right here is where they had the issues with the Sioux Indians. And they wintered up here north of Pollock. So that's 1804. Okay? What were they looking for? Stuff to buy, stuff to take home. Beaver, especially, because they all wanted hats. So they killed millions of beaver. How many people have seen the movie The Revenant? That is a true story, by the way. The movie is totally stupid, but it's a true story. Hugh Glass did get mauled by a bear in South Dakota and whatever, but there are no damn trees where this happened. So we're all watching the movie going, there's no trees where this happened. Where'd all these trees come from? If you've seen Dances with Wolves, and very few people in here are probably old enough to remember Dances with Wolves, that was filmed very close to where we farm. Some of it was within 3 miles. So that's what it looks like, rolling prairie. But they wanted the beavers, okay? And then they took the beavers, and then they brought in the settlers, and then the settlers cut down the trees that were in the valleys, because the only place there were trees were in the valleys, because that's where the beavers were, and building their little dams. And then we started to overgraze, and then we started to do tillage, and then it started to flood, right? We replaced these circular biological systems were being replaced by linear systems focused on extracting resources. We built the railroad so we could ship stuff out. The speed of degradation was initially limited because we didn't have the energy to transport things. Prior to the railroad, you couldn't really ship a bunch of stuff out. You shipped out a bunch of beaver hides down the river and buffalo bones and stuff like that, but it wasn't huge. This changed abruptly with the Industrial Revolution in the 1800s. Development of coal and other fossil energy meant the lack of energy was no longer a limiting factor. We took away that feedback loop. They were telling them, don't do that, don't do that, don't do that. We no longer had that don't do that thing, or you can't do that. Fossil fuel was the engine for the Industrial Revolution, still is our engine in the UK and elsewhere. 1850, they produced 2.3 million metric tons of steel annually in the UK. If they would have used wood to do that, that's the way they used to do steel, it would have required cutting a forest of 97,000 square miles every year of forest instead of using coal. That's greater than the total surface area of the UK. So they would have had to cut down all their trees every year, which obviously doesn't work on a biological system. But that allowed them to build steam engines and rails and iron and ship it to the US and get railroads out to where we use. Use of fossil fuels allowed society to ignore feedback loops and these constraints that would limit degradation. Transportation systems made it possible to increase the speed and extent of extraction of resources. I have a young fellow who is a ag advisor to John Thune, who's our senator. And he's an engineer. He knows nothing about ag, so he kept calling my daughter, who he went to school with, and she's an engineer, and he knew her dad knew something about ag, so he kept calling her. She finally said, here's my dad's telephone number, call him. You know, quit bothering me, right? And we were having a discussion. One day he said, well, railroads are good, aren't they? And I said, why don't you look at the crow rate in Canada? The crow rate in Canada is a subsidy for export of grain on railroad. They get a cheaper price coming out of the prairies going to the West Coast because the Canadian government paid for building the railroad through the Crow's Nest Pass. But it made grain more expensive for the cattle people, so the cattle started to disappear because we've subsidized grain transportation out of the country. So then the Canadian government started to subsidize the cattle growers. So when my wife Ruth was working as an ag person in Canada, one of the things she did is send out checks to guys having cattle because their feed was too expensive because they subsidized grain going out, right? So, are railroads good? It depends how you use them. It's like any technology. Transportation systems made it possible to operate linear systems by bringing in inputs and taking things out. They allowed us to take the circle out. So our nutrients are going away. Native American communities in central South Dakota before introduction of the horse were agriculturally based with mixed cropping and hunting. This hunter-gatherer, Indian on a horse chasing a buffalo thing only was 300 to 400 years, if that. Before that, they were farmers. If you lived where we live and tried to be a hunter-gatherer, you'd starve to death. You needed to have agriculture. The Lewis and Clark expedition purchased corn from Native American farmers near Bismarck, North Dakota when they went by. Early on in my career, I did a meeting in North Dakota, and I said, I think you guys need to be looking at putting corn in your crop rotations, which are basically wheat and summerfell. You need to be putting corn in there and some other things. And one of the researchers from USDA jumped up and said, we can't grow corn in North Dakota. The research station was 3 miles from Fort Lincoln, where Custer took off to go to the Little Bighorn, was Fort Lincoln, but they have a Native American site there that talks about how they farmed 3 miles away. He didn't go there and look. And I said, you know, Lewis and Clark bought corn from the Native Americans when they came through here, and I think the USDA should be able to develop farming systems almost as good as the Native Americans were, if they worked on it. When the animals were removed and replaced by tillage-based farming and overgrazing by domestic animals, severe degradation occurred. How long did it take? Less than 50 years separated statehood and the Dust Bowl in South Dakota. If you read the book Dirt, that photo on the front of the book was taken in South Dakota, not very far from where we have our farm. Okay? And not only did we have Dust Bowl, we had flooding. So droughts and flooding were both going on. Well, just because we had extraordinary years. No, we destroyed the ecosystem, okay? And so our response as white European males to an ecosystem problem is to build something. So we're flooding and having droughts at the same time. We passed a law to put in large main stem reservoirs. So we have 4 big reservoirs in the state of South Dakota, 1 in North Dakota and 1 in Montana. So there's six big main stem reservoirs in the Missouri River that control water all the way from the mountains till it gets to the border of South Dakota. So there's a photo of 2 of them. This is the big meander we talk about. This is Big Bend Dam, obviously. And Lewis and Clark talk about this big meander because they went around it and measured how far this was and stuff. So we knew when they were there, and we knew when they came past here, we're about here. This is the Wahi Dam, this is Pier. Okay? So there's the Wahi Dam, which is at one time the biggest earthen-filled dam in the world before Aswan High Dam. So there it is. Isn't that wonderful? And that building right here was supposed to put in irrigation, pump irrigation water, because you couldn't possibly grow crops without irrigation in central South Dakota. So we had to have some irrigation too. Now, they were wrong in terms of thinking they can control the river. Here's 2011 when all of a sudden the water got too high and they had to open up the auxiliary tunnels. 6-foot diameter tunnels, wide open. Pretty impressive sight. If they wouldn't, they would have overtopped the dam. So everybody decided that, gee, we're going to irrigate now. So a bunch of our farmers started irrigating high-pressure irrigation systems. So you put on water at an inch of water in 40 minutes. Pretty slow, right, compared to whatever. And then we ran the water down the hill back to the river because we didn't have a lack of water. We had a lack of water going in the ground. So that was dry land or irrigated. So when they put it on with irrigation, it went back to the river. So who's responsible? What's responsible for all this stuff? Well, present government, economic, and social systems favor degradation over regeneration. Gross domestic product means gross. If you double your energy use to produce 10% more, you increase your gross domestic product and everybody's happy. If you degrade your soil, nobody cares, except your kids or your grandkids or whatever. And then people say, well, I didn't know we had a problem. You know, we just didn't know we had this problem. Well, Plowman's Folly was in the 30s. If you haven't read Plowman's Folly, you maybe should. It's sobering. Talk a lot about cover crops. Conquest of the Land by Loudermilk talks about going to all these countries, China, Israel, the land of milk and honey. Looks not like you don't know how that could be, but it could have been. But it got degraded so bad you can't really tell. The Worst Hard Times, about the Dust Bowl. Dirt by David Montgomery. All of those have said, geez, we got to quit doing that. The new one that you really need to probably read, and the basis of a lot of what I'm talking about today, is Darren Qualman's Civilization Critical. Talks about all this stuff. But there's also Future Eaters, right, by Tim Flannery from Australia, who was on TV last night on BBC, because he's now head of environmental sciences for Australia, and everybody called him a kook 30 years ago or 25 years ago when he wrote Future Eaters. We should have been, or we should be, paying more attention. You know, we tend to get into our camp. You know, oh, them guys over there. You know, look at the science. I'm a chemist. We look at the science. We got some real problems, and we've had them for a long time. I remember my parents talking about the dirty 30s. They were old enough to remember that, and it was always sobering. So the first thing we have to do is try to stop the bleeding, and that's really where Dakota Lakes came in. The farmers that were having all the trouble with runoff and whatever came under the irrigation and we got to talking about it because I was doing research out there, and they wanted more research. And I said, if you're going to get more research going, then you need to have a place to do that research. And they said, well, we'll go with the government and get the land to do that. And I say, you do not want to do that. There's 4 people in a bar really late at night having this conversation, okay? That's when all good things get done, especially very late at night. 2 people from the university, 2 people that were farmers. And I said, you don't want to do that because you'll lose control and you end up with all these little tiny plots. You want to control it. So they put together this organization. It's not important how we do it. We can talk about that some other time, but owned by farmers. Everything's owned by the farmers. 11 member board of directors. Me, the research managers, work with the board of directors and with FCSU. So we bring those 2 together, and it's not an easy job, but it's important. So there's our main station right on the Missouri River. We have both irrigation and dry land. You can see it's not real fancy ground. There's what our native vegetation looks like. It's just a mixed grass prairie. Trees only grow in major drainage ways. I went to Australia and showed this slide one time, and the lady, somebody in the audience says, where are the trees? I said, Paul Bunyan cut them down. Because everything in Australia they farmed was trees when they started. I said, Paul Bunyan cut them down. They had no idea who Paul Bunyan was. You know, so you got to be careful what you do, because I thought, well, that's a really cute response. And just got this blank look. So we have this mission statement. We're not a no-till farm. We've never done tillage there, but we never started out just to be a no-till farm. We set out to do these things: stabilize the economy, promote diversity, increase production efficiency, minimize negative environmental effects. We're goal-oriented. It's like John Kennedy didn't say, well, we're going to build a bigger rocket. And if we get a big enough rocket, we might be able to maybe think of putting a guy in space. All right? What did he say? We're going to send a man to the moon by the end of the decade and bring him safely back to Earth, which is a good thing to add on the end of that, you know? I mean, okay, that part's important, right? We don't do that in our farming systems and our ag research. We don't do that kind of approach. So here's the area that we primarily have impacted. And there's 2 stars there. The one on the east side, that's the state of South Dakota. The one on the east side or the right side is the James Valley Research Center, where the water was supposed to go from the dams because it was a big flat area and they could gravity irrigate it. Remember, 1930s. And the one on the left is the one at Pier, which is along the river. But there's 3 crop reporting districts in that thing that we primarily impact. Now, we impact a lot further away from there, but let's just look at what we've done. We've increased the productivity between 1986, before we were, and before anybody was no-tilling and doing the right thing, from 1986, which had about the same rainfall as 2014, or 2014, $1.6 billion. Using the same price the night before we went to talk to the Board of Regents from the state as a board, and we showed them that number. Okay? We didn't achieve this because we set out to improve yields. Rather, we were going to manage the ecosystem better. The light bulb was not invented by incrementally making candles better. Okay? Think about that. Was one of my. I stole that from somebody, right? It's like the pig and the chicken statement they always make, right? When we had breakfast this morning with bacon and eggs, the chicken was involved and the pig was committed. Okay? And I said that to some reporter the other day, and he just laughed and thought it funny. And I told my wife, I said, well, Lon thought that was funny. She says, that's so old. Everybody's heard it. And I said, no, they haven't. There's people that. So let's look at research from the standpoint of water cycle, energy flow, mineral cycle, community dynamics. Okay? Does the rain feed plants and recharge groundwater? Does it run off, percolate, cause erosion, water problems? Drain tile. If you need drain tile, your water cycle's broken. The guys had a broken water cycle. Now, we've fixed that. So there's our irrigator. We're putting on 2 inches of water in 9 minutes, and you can walk right behind that irrigator and not get your feet muddy. And Jeff Mitchell from UC Davis brought a bunch of people out years ago, and we walked. First thing we did is walk them behind the irrigators, and then I had them. Right? If you do irrigation, and you can do that, you go, oh, how did that happen? No-till is not about lack of tillage, about managing soil, water, structure, soil biology, carbon compounds. You can't do any of that stuff if you do tillage. In nature, tillage is a catastrophic event. It doesn't happen in natural systems. And so the first thing we had to do is get rid of the tillage. And we found that out by accident, just like other good things that people do. So there, we keep the armor on the ground. This is all fairly simple stuff. You see all those macropores there, all those big holes. And those are night crawlers for us. Monty's got night crawlers. I don't know if you're going to have night crawlers or not, the big permanent burrow dwelling earthworms. But they will cycle a huge amount of residue. If you think too much residue is a problem, they will cycle that for you. They live in those burrows, and they reach out and they pull it up and they pull it down in the burrow, and they grow fungus on it, and they eat the fungus. And they only leave that burrow when it's really wet, so they could drill a new hole. They only leave that burrow when it's really wet because they can't find it again if they leave it. They can only have sex if they leave it, so that, to have sex, they've got to be really motivated. But any two of them can have sex, right? Because they have both parts. And then I always finish that up. We had the governor of South Dakota out a few years ago, and we're showing him this, and I'm out there in the field showing him, I'm going through this part, and my wife is standing behind him going like this. Because he knows the next thing I'm going to say, and I'm going to, and now they can get insurance and get married. Governor thought that was funny. He said, write that down. That's 20 years of wheel track if you've been around irrigation. Okay? That's 20 years of wheel tracks. 20 years. So, there's cover crop, there's planting green with cover crops. Take the E out of ET, make water into the soil, maximize the water holding capacity of the soil. That was our goal. That's a good idea. For irrigation, it's imperative for rain-fed guys because they can't pump more. If an irrigator wastes some water, he can pump more if he has more. If you're in California, you may not have more, right? Or if you have enough horsepower to get you more. But a dryland guy, he doesn't have another chance at it. Ecosystems that harvest sunlight energy and drive all their process. If we remove products from the ecosystem, it removes the energy and the nutrients. So when you take it and ship it out, it leaves, including the energy. So taking all the straw and all those things, you take the energy away from those little animals living in the soil. Is your energy constant or finite? The sun's going to come up tomorrow. If it doesn't come up, we just better have one big-ass party because we're only going to last about 4 days, right? But it's going to come up. If you own the land, you have the sun. If you buy fossil fuel, it's dangerous. It causes unintended consequences. It causes degradation when it's produced. It's a mess when you go to some place they're drilling for oil. And it's external, so you have to keep buying it. 80% of the total input costs in agriculture right now can be traced to energy. The average price of wheat in 1970 was $1.37 a bushel. The average price of a barrel of oil was $3.39. So you're using something that costs more and continues to go higher in price to produce something that costs less and is going down in price. Doesn't sound like a good market plan to me. Right? I did a meeting in Montana a month ago, and they're still on this model of, boy, we just got to get more exports. Got to get more exports. I showed this. And then I brought up the fact, and that came from 1973 when they made the wheat deal with Russia. Earl Butz, farm fence row to fence row. Boy, these secretaries of ag, we really got some special ones, don't we? Earl Butz and the guy we got now. get big or get out. We're going to farm fence row to fence row. And we got to send this wheat to Russia. In 2018, Russia became the largest net exporter of wheat in the world. In 2019, Russia and Ukraine, the two of them together, exported more wheat than the U.S. produces. So if we're still playing that game of we're going to grow wheat for export, we got something wrong. Takes the energy 1 gallon of diesel fuel to manufacture, transport, and fly 5 pounds of N. So 150 pounds of N is equivalent to 30 gallons of diesel. Woo! Oh, damn. But if I do no-till, I save 5 gallons an acre or something like that, right? Or 2 gallons an acre. It's not important if you're putting on way too much nitrogen. Use of inorganic nitrogen fertilizer was essentially zero prior to 1950 because we had to have the Haber-Bosch process, right? In 2010, it was 100 million metric tons. So from 1950 to 2010, we increased it to 100 million metric tons of nitrogen. The number and extent of hypoxic zone in the world's oceans has doubled every decade since 1960. And I don't know if that correlation means causation, but I think it might. The fossil fuel input in agriculture 120 years ago was essentially zero. And 120 years ago, it'll probably have to be zero again. So we maybe should start trying to figure out how in the hell to do it. I don't know. Not my job. The Dakota Lakes Research Farm will be fossil fuel neutral by 2026. So we're going to produce, that's one of the moonshot things. We're going to produce as much oil as we use. So we press our own oil seeds. The nice part about that, if I export the oil, send the oil someplace, so off the farm, I've exported the sunlight, carbon, and water. Right? Carbon dioxide and water and sunlight. That's all I've exported. That's what's in the chemistry thing. That's what's in the oil. There's no nutrients in the oil. If I feed the meal, which we do, then I keep the meal, I keep the nutrients on the farm. Are the nutrients available for plant use or environmental services, or have they been leached, eroded, or transported from the landscape, sent to China or the ocean? Ecosystems that leak nutrients turn into deserts. That's a definition of desertification. So if you're sending all your nutrients away, harvesting alfalfa and shipping it to Saudi Arabia, you've shipped the water and your nutrients to Saudi Arabia. Probably not a good long-term plan. A 120-car train of soybeans contained 400,000 pounds of phosphate. And it's not coming back if it goes to China, and even if it goes to Arkansas from Illinois. Now you've got the phosphorus closer to the ocean where it's a bigger problem in terms of hypoxic zones. If it goes deep and comes out sideways as a saline seep, it's still nutrients. Some of you guys probably know the Hefty brothers from South Dakota. Darren, you probably got the Hefties in the east, don't you? You got Hefty brothers over there in Illinois? Yeah, sure. And so I had Darren there one day trying to get a bunch of money for drain tile from the Corn Council, for God's sake. And I started asking him, what's in a drain tile? What's in a saline seep? And when he said saline seep, he said salt. Well, he forgot I was a chemistry teacher. Take an acid and a base, you make a salt, right? There's a lot of salts. What kind of salts, Darren? He didn't know, just salt. The salts that are in there are things like gypsum, calcium sulfate. That's fertilizer. Calcium carbonate, that's fertilizer. Calcium nitrate, that's fertilizer. Darren also sells fertilizer. So I gave him about a 20-minute master's defense type questioning session. And we walked out of there, and one of the farmers said, well, I felt sorry for him. I said, he's making millions of dollars off of you dummies. He should know these things, right? He doesn't care as long as he can tell you something. Weeds and diseases are nature's way of adding diversity to a system that lacks diversity. Doesn't mean we don't use herbicides, but we see weeds and diseases as a way of adding, an insect way of adding diversity where we don't have diversity. We have not had to use an insecticide. This will be the 18th year. We do use some herbicides, right? I use almost no fungicide. Nature's efforts to add diversity can be countered by adding beneficial diversity of your own. So we see Mother Nature as an opportunist that's trying to fill a niche that we haven't filled. Small amount of organic matter by weight is a big impact on pore space. The biggest thing that we're missing is organic matter in our soils. We've mined them out and they don't function like they should until we put it back. Within all texture groups, as organic matter increase from 1 to 3%, available water holding capacity doubles. You get around 4%. Counts for more than 60% of your available water holding capacity. So we focused real hard on adding organic matter and getting roots to different depths. If you look at the native plants, they have roots that go 7 or 8 feet deep. None of our crop things do that. I don't think we're going to be able to be long-term regenerative or whatever you want to call it. We've got the regenerative name instead of sustainable. If we don't have perennials in the system. And for people in California, you've got some perennial species that you use. Out in the prairies, we're probably going to have to use native grasses. So we've started a crop, taken one of our rotations and changed it on the farm so we have a perennial sequence in there. I told the guy that works with me that in 20 years we'll have some really good data. He advised me to eat my oatmeal. If you're going to be around for that, right? But the system in Argentina they used to have with 7 years of grazing and 7 years of agriculture worked really, really well until they screwed it up. Mother Nature makes maximum use of water and nutrients and having webs of mycorrhizal fungi and other tricks, and she uses animals, big ones and small ones, as part of the system. And when you think about all that stuff, I mean, the phosphorus we put on, I think we can do really much better with the phosphorus if we don't do the tillage because we have the mycorrhizal fungi. And we have some data that we're developing that really shows that, okay? And then if you drive through the mountains and you see the trees growing out of a rock, just ask yourself, how in the hell does it do that? I mean, really, how does it do that? And it takes a whole community of these little guys, big guys. In dry or brittle climate, soil biology slows during times of low soil moisture. The rumen of grazing animals remains moist, continuing biological processes. In cold climate, soil biology slows like we have during times of low soil temperatures. The rumen of a grazing animal remains warm, continuing biological processes. Okay, that's one of the reasons for having animals in the system. So we will produce a crop of wheat, and then after the wheat is harvested, we'll grow oats and barley and peas and whatever, what you guys would call a cover crop, we've called a forage crop forever. But that's a niche where we could put in that, and then we swath it. So there it's swath, right? And when it's at optimum moisture, there it is in the beginning of the winter. That's my orange glove. If the cows see me with my orange glove, they know I'm moving the fence. That's what it looks like underneath there. Stays nice and green. And then we use our irrigators where we have irrigation machines. We use them to make the fence to move the cows. So it's a little easier to move the fence by pushing a button and pull the posts out and move them, especially when the ground's frozen. And they do we move it every day, and they do a nice job of spreading their own manure. And that armor is still there because we have the wheat straw from the wheat crop still there, and they just cycle the other stuff, but they leave the armor there. The only way to produce human edible protein on marginal land is to use a ruminant animal. This whole discussion of getting rid of animals is just stupid. It's not looking at natural systems. Natural systems were predominated by animals. You know, our ancestors, that's what they did, is the animals processed the plant materials that we couldn't eat, and we ate the animals. So, yeah, we're going to eat some plants, we're going to eat some animals if we're going to survive. So the answer to feeding people is 40 million more cows and more goats and more sheep. Fortunately, doing all these things is only stopping the bleeding, okay? Agriculture cannot do this alone. We need all of society to have a brain transplant. Our farmers, when somebody comes, I want to be a no-till person, they say, go down to Dakota Lakes and get your brain transplanted first. So you think of things differently. Ecosystem degradation is a symptom. Just a symptom. It's not a problem. It's a symptom that we have indifference, greed, jealousy, selfishness, ignorance. And I could go on as the cause. Society has to be focused or we're not going to survive. Bureaucracies, governments, and corporations are operated by people with limited tenure and short-term goals. Department head in a university, their goal is to last for 3 years and get a promotion or go to a different job. A guy who is in Congress or the president or whatever, their job is to get reelected. They don't look beyond the next election if they look that far. A lot of people in society, they're worried about next Thursday. And we have to change that. Society and landowners and farmers deserve to have long-term research. The climate will change. We have, at Dakota Lakes, our board goes through a process of looking forward 600 years. If we do this, Monty, you said 3 this morning, right? Or 1,000. He said 1,000. So we're only looking 600. We're short-termers. You know, if I continue to do this for 600, if we try to do what we're doing now for even 100 years, we're just screwed. You know, and I don't know how to change that. Now, the climate will change, but we'll still be a continental climate. You'll still be a Mediterranean climate in California. But you can temper that. But degradation of the ecosystem is more of a potential impact. You can buffer those changes in climate if your soil is more resilient and if your farming system is more resilient. Doing the right thing environmental is almost always the correct economic approach in the long run. Think about that. Best time to make a transformational change, have a brain transplant, and take a moonshot was 600 years ago. Right? A little bit late for that. Second best time is now. Right? We may not get another chance. I mean, I don't tend to be a screamer or a whatever, but if just looking at all the logical things, you look at the history. Take the E out of ET, right? Make all the water that you get go through a plant. That's what that means, ET, evapotranspiration. Evaporation is not a good thing. That means we've wasted the opportunity to use that water. And take the T out of can't, and like the lady last night was talking about. So I do have some time for questions if you want to. If you want to throw rocks, you can do that too.
I'll try to be Phil Donahue here. Any questions about what's going to happen in the next 600 years?
Tom has a question.
You collaborate with the Land Institute in Kansas, and what are they up to?
Well, Wes Jackson and I have had a fundamental disagreement for a lot of years. And, but, you know, I think he's done a good job of collecting money to do stuff. But I haven't seen him put out something that really works. And Kearns being one of them. There is a book out that they have a chapter in called Prairie According to Beck. Some guy wrote a book one day, and he discusses this whole thing with Wes Jackson and I, which is kind of interesting. But if you put a plant in the prairie ecosystem and you harvest just one of the plants in that diverse system, it becomes a decreaser. And a perennial plant's main goal in life normally is to preserve itself instead of produce seeds. And so if you're trying to compete with annual cropping and produce grain, it's going to be difficult. Now, if we do the thing where the 7 and 7, We have the good functioning prairie. And then every so often we have this oh shit moment that happens in the prairie when everything goes away for a while. And we use that interval to do some cropping and then come back to prairie, it might be. I think where you're doing trees, there's lots of opportunity to do stuff where you have annuals and perennials underneath your almonds. Okay. Notice I called them almonds. My cousin who's now dead, I think his kids now run the operation. They have almonds at Modesto. So when I was at Davis, I would come down and help prune almonds and knock the mummies out and do those kind of things, right? So I think there's opportunity to do that. And I think the new big might be small, where we can come, have trees interspersed with crops, or we have perennials interspersed with annuals where we work in between. But it doesn't fit the model of that I'm going to get bigger. And I have this 200-foot cedar. I mean, how big can you get? I mean, we got guys that got 120-foot cedars or some damn thing like that in Montana. I mean, how big can you get where it doesn't make any sense? And and so that's, the concept of having to have the perennial to cycle is exactly right. It's just how you're going to get there. But you've got to cycle the nutrients. The answer to saline seeps is perennials, because you got to take the water from that 3-foot to 6-foot area and bring that out and the nutrients with it, bring it up to the top. But if you take that hay off and ship it out, then all that goes away too. So then you need the animals to cycle the hay right where it's at. And we do some grass seed, and then we sell the seed, and then we cycle the biomass. I can hear you, that's fine.
Okay, of your founding farmer group that formed Dakota Lakes, are they still all involved, and how?
Some of them are dead.
How aggressively did they make changes based off the research you found? Were there some like, I'm skeptical, or were they all on board? And
the interesting question is how many people are still involved and versus committed, and some are committed because they're dead. So there's some really interesting thing there. Every one of them we started, we had 11-member board of directors. When we started the farm, every one of them was an irrigator, and every one of them was conventional till when we physically put the farm in. And I brought this plan, and I said, I know that if we no-till, we can make the water go in better and whatever, which means we can put on lower pressure systems and smaller pumps and smaller pipelines and all this stuff on the irrigated part of the farm. And we need less machinery. But if you want us to do the tillage comparison thing or whatever, then we'll have to pay more money. And the president of the board, who's still alive, Ralph Holdsworth, he's not on the board anymore, but he just said, I know how to farm with tillage. Let's no-till the damn thing and see what we can do. Okay? And yeah, most of them guys now don't irrigate. Ralph doesn't have irrigation. I mean, most of those guys that had irrigation, because it doesn't make any economic sense to irrigate if you can use the water better, so they don't irrigate anymore, and yeah, they're highly involved. So 98% of the guys in that area are no-till. And so we went from doing one crop of wheat every 2 years. That's what they did. Right? And I showed you that $1.6 billion. So now they're producing corn and whatever. They now put a corn ethanol plant at Oneida, where they only did wheat every other year. And they closed the highway in 1987. They closed the highway because of blowing dirt, just like California. Right? We don't have that happen anymore. When the governor came to visit, I took out the local papers there. Sometimes would be 30 years ago this happened, right? And I went and got one of those papers that had all these photos from 30 years ago when they closed the highway, and I gave him a copy of that. And I said, if you want the, Cliff Notes, for you guys old enough to remember Cliff Notes, if you want the Cliff Notes of what we've done, this doesn't happen anymore. Okay? So yeah, everybody's committed. Is everybody doing the whole thing we're doing in terms of trying to put the perennials in and stuff? No. Does everybody do cover crops? Not even we do cover crops on everything every year because we don't have the water. We pick and choose, right? It's not about doing cover crops, it's about using them as a tool when we need to do the water cycle, nutrient cycle better. I mean, no-till is a tool, cover crops is a tool. These are all tools. But yeah, we have a lot of very highly motivated people that are involved. Almost nobody's an naysayer say that doesn't work here. Go to Montana, they say that. They go, no, that doesn't work here.
Is your neighbor Gabe Brown accomplishing everything that he's claiming to be doing?
Gabe Brown's not a neighbor, he lives 4 hours away.
Well, you know, for us, that's a neighbor. Okay.
The thing I say about Gabe Brown, when I met Gabe Brown and Jay Fuhrer, both guys are very famous, they were both conventional tillers. And that's a true story, and Gabe will say that. And they had come to visit the farm, and Jay was an NRCS guy that had gotten all these awards for building terraces and waterways, which I didn't know when he came. I just knew he was with NRCS, and I'm showing these guys stuff, and I said, yeah, you got these NRCS guys, they want you to put in terraces and waterways. And you're just treating the symptom. The real problem is the water's not going in the ground. And I just kept saying that kind of stuff all day, you know. And Jay went home, and he told me later, he said, I went home and just was devastated that I spent my whole life doing this. And it was the wrong thing to do. See, and that's a little bit of this talk. I mean, we've spent our whole life doing the best job we can of doing the wrong thing. And we've got precision agriculture that lets us precisely do the wrong thing better. Right?
Precisely.
But we haven't gone back and asked, are we really doing the right thing here? And yeah, that's what I want to do tomorrow is try to address a few of the things that we think may have some, but I have no idea where we're going to be in the long run. But we got to do something different we're doing now. So.
Only 15
We
seconds
got
to
15
spare.
seconds and then they're going to shoot me.
Tristan's got a question? I want it on a video.
You alluded to the night crawlers pulling in organic matter, growing fungal and mycorrhizal colonies on it. Have you done any research tracking different classes of mycorrhizal colonies affecting your carbon cycling at all?
Not different types of mycorrhizal fungi, but we do have a study where we've drawn our phosphorus soil test levels down to very low levels. Okay, so phosphorus soil test levels are not how much phosphorus you have, it's how soluble it is. So the Olson, the Bray, the Malik, Dr. Mulvaney can fill you all in on this tomorrow too, but the Bray, the Olson, the Malik, and those guys are all just ways of trying to pull out, see how soluble the phosphorus in the soil is, so whether the plant can get it or not. If the plant is working with mycorrhizal fungi, it can get phosphorus at levels of solubility way below because the mycorrhizae can drill a hole in that thing and solubilize the phosphorus. So none of our land that we farm, irrigate close to the river there, they all have Olson soil test P levels below 5 parts per million. And everybody goes, oh, and we grow 260 bushel corn. We put some P on as starter. Okay, so we still put some P on because we think that's probably a good level because it's going to limit how much P moves off-site to the water, and we're going to just maintain where we're sitting until we know more. But I do have a study where we have that level, and then we've added, in the last 6 years, we've added 300 pounds of MAP in addition and 600 pounds of MAP in addition and get no response in terms of yields and stuff. So it's kind of interesting, but I will quit, but see you tomorrow.